Hello students. This week we'll be doing chapter 6, chemical bonding 2. So in this chapter 6 you see we talk about the hybridization. It says the valence bonding and molecular orbital theory, but I'm not going to do the molecular orbital theory. I'm only focusing on the hybridization. So you should know what is this hybridization? Hybridization is so when these two elements form bonding at the beginning before forming bonding, these are elements. So element is just by itself, it's in the atomic form. So atoms has atomic orbitals. When it from combined to bonding the now it's a molecule, right? When two or more atoms is a molecule, now you have molecular orbitals. So these molecular orbitals combine and form the more stable structure. We call that molecular orbital theory. And so then we have in molecular orbital theory, we have hybridization. Um, so in hybridization, you see, if you take the hybridization, there are hybridization including sp hybridization, sp2, sp3, sp3d2, d and sp3d2. In the exam, I may ask a question, look at the molecule and what is the hybridization. So let me take a simple example. So here if you see H2S, I'm saying by just looking at the molecule, the hybridization is, I'm saying it has, okay, it is sp3 hybridization. So how do you say that? How do you say the hybridization? By looking at the molecule. And then I look at the CH4 molecule, I'm saying, okay, it is also sp3. And then, so I'll tell you, by easy method, by looking at the molecule, how to tell the hybridization. Mainly, you need to know the Lewis structure. Without knowing the Lewis structure, it's very difficult. So first, let's see, by taking the water molecule, how do we predict the Lewis structure hybridization? So my water molecule H2O, okay, oh, sorry, it's my H2O. So I know when you draw a Lewis structure, I looking at the valence electrons, I looking at my center atom. So center atom is oxygen, hydrogen, and then I look at the 1, 2, 3, 3, 4, 5, 6, 7, 8. So what is my hybridization for water molecule? I have how many electron domains around the center atom? I have 1, 2, 3, 4 electron groups around the center atom. My hybridization is sp3. What do you need to look at it? You look at number of electron groups around the center atom. What does sp3 means? S orbital, one s orbital. If you remember quantum, remember there are subshells, right? S orbital, p orbital. One s orbital combining with three p orbitals. This superscript 3 means for three p orbitals form one s, three p's. One s plus three p gives sp3 hybridization. So then you have how many orbitals together? Four. For each orbital represented by a domain, that's what 1, 2, 3, 4. So that's how we say, okay, it is sp3 hybridization. Let's take HCN molecule, HCN. So I'm taking a new molecule which is HCN. Let me draw the Lewis structure. When you draw the Lewis structure, it's very important. By this time, you know how to draw Lewis structure completely. So I draw one, two, three in hydrogen. So this is my HCN Lewis structure. How many electron domains? One, two, two electron domains. So it should have only two um, shells, right? So my hybridizations SP, SP2, SP3. So two domains. It's SP. This hybridization is SP hybridization. This is the easiest way to predict the hybridization. So if you have two electron groups, basically what is the geometry for two electron groups? Linear. Two electron groups, if it is a linear geometry, it is sp s then three electron groups. Three electron groups, it is sp2, which is what is the geometry? I would say trigonal planar, right? Trigonal planar, and then four electron groups, sp3, tetrahedral geometry, five electron groups, sp3d, six electron groups, which is octahedral, it is sp3d2. So that is how you predict the hybridization by looking at a molecule. So let me go to the one area here. Let me go to the one question. Let's take one question and discuss. You can look at the pi bonding. That's important too. Bonds interact along the axis is sigma bonding. Perpendicular to the axis is pi bonding. And then I want to take a question. Okay, let me take a question. So my question is, what is the hybridization and bonding scheme for bromine trifluoride? So now I have a question. I don't have any answers. I have only bromine trifluoride. Okay, so I'm getting my whiteboard back again. So it's my question, bromine BRF3, right? So this is BRF3. So now what I want to do is draw a Lewis structure, but I want to find the valence electrons. Bromine 7 plus 7 into 3. So it's altogether it's 28 valence electrons. Br is center atom. F, F, F. So always one bond means two electrons gone. 1, 2, 3, 4, 5, 6, 8 gone. 9, 10, 11, 12, 13, 14, 15, 16. Okay. Now let me see. Okay. So now 8 electrons, 24 electrons gone, and I have 28 electrons. So I have 4 more electrons remaining. I put it here. 1, 2, 3, 4. Now I finish my Lewis structure. This is my correct Lewis structure. So what is the electron geometry of this compound? Electron geometry, what do? You look at number of electron domains around the central atom. I have 1, 2, 3, 4, 5. Whenever you have 5 electron groups, the geometry is trigonal bipyramidal. So my electron geometry is trigonal bipyramidal. What is molecular geometry? In molecular geometry, you take the lone pairs and the bonding pairs separate. So I have three bonding pairs, two lone pairs. My shape is T-shaped. And then I'm taking the hybridization, five electron groups around the central atom. My geometry is sp3d. One shell, four, five. So this is my hybridization. Okay. So this is how you predict the hybridization, which is very important in this Kept hope this short video helpful for you and good luck.